Yeah, hi guys. So in this video, we are going to do graphical study of the linear motion. Graphical study of linear motion. We will draw different types of graph. For example, velocity time graph, displacement time graph, acceleration time graph, and we will analyze it for various different types of graphs. So with the help of that, we will learn how to analyze graph, and with the help of graph what all things we can get. Okay. First of all, I am going to draw a graph that is called displacement time graph. Displacement time graph. Displacement I denote with the letter D. Displacement time graph. Displacement time graph. So first type of graph is displacement time graph. Okay. Here, as the name suggests, it is go here, this side. Right. So here you are representing different types of graph. So it's a displacement time graph. So time we are taking in second as a unit. Displacement which we are representing by d with the arrow because it is a vector quantity. So SI unit is meter. So we will draw different types of displacement time graph. Okay. Different types of displacement time graph. We will try to draw. So first, displacement time graph of an object can be like this. It can be this way, right? Object 1. For object 2, it can be this way. For object 3, it can be this way. Object 4, it can be this way. Object 5, it can be a straight line basically. So, this one. So, I am trying to draw a graph which is perfectly perpendicular, which is parallel to y-axis. It is perfectly parallel to y-axis. Okay. So this is another type of graph, and moreover, there can be different other types of graph also, right? So let us call it displacement time graph for body 1, displacement time graph for body 2, displacement time graph for body 3, displacement time graph for body 4, right? Displacement time graph for body 5. Now, these 5 different graphs you have been presented with, and you are being asked to comment on the uh, type of motion. So, displacement time graph is of great use, right? With the help of displacement time graph, we can comment on velocity, right? Whether the velocity is changing with time or the object is traveling with the same velocity, right? So we can comment on that. So let us start with case 1. Object 1, what can we say about this displacement time graph of object 1? With the passage of time, we are seeing that the object 1 is not, the displacement of object 1 is not changing. With the passage of time, the displacement of object 1 remains same. So that's why it is just parallel to a particular point. So displacement is not changing. So that's why one shows that the body is stationary, right? Because with the passage of time, displacement is not changing. So suppose this is the starting point from which we are calculating the distance. So we calculated that, okay, so this is the body is here, okay, body is here. So its position is not changing, displacement is same. So it is stationary, right? So now let's jump on to graph of object 2. displacement time graph of object 2. What can you say by seeing this? One thing is pretty much clear, that displacement is changing with the passage of time, right? With time, displacement is changing, so body is moving, right? Body is moving. In fact, body is moving with uniform velocity. Body is moving with uniform velocity. Uniform velocity. How? Body is moving because the displacement is changing with the passage of time, right? But how uniform velocity? Uniform velocity because the slope is constant. At any point, you go and find out the slope, right? So velocity you can derive. You can get the velocity from the displacement time graph. It's the slope of the displacement time graph. Slope of the displacement time graph. This is slope of displacement time graph. Okay. So you can say that slope of displacement time graph will give you velocity. So what is the slope? Y upon x. What is represented on the y-axis? The distance. You calculate it. Say this, right? This by this, right? You can take any line. So every time you will find same slope, right? Because both of these lines are parallel now. So this corresponding angle will be equal. You will be getting the same. You will find that the object is traveling with uniform velocity, right? Okay. So let us comment on graph number 3. What can you say? Okay. The slope of the graph is changing. How to calculate the slope? At this point you can calculate, you can see the tangent is in this direction, right? This point you see the tangent is at this direction, right? So various point velocity is changing, right? Body is moving with non-uniform velocity. Body is moving with non-uniform velocity. Yes. Why? Because slope itself is changing. Because slope is changing. Slope of the curve is changing because slope of the curve is changing. Slope of the curve is changing. Fine? Because slope of the displacement time graph gives us velocity, and slope is changing continuously, right? So you can say that the body is moving with non-uniform velocity, right? Fine. So velocity is increasing or decreasing? See, the value of the slope is increasing, so velocity is increasing, right? Velocity is increasing with the passage of time. And let us analyze the graph of object 4. What can you say? With the passage of time, earlier the graph, the tangent was this, right? Now the tangent is this. So in this case also, you can say that body is moving with non-uniform velocity, right? In this case also, body is moving with non-uniform velocity. That is something which we can say. Now the last graph. Graph of object 5. Think about, comment what we can comment by saying the graph of the body 5. Is it possible to have this kind of graph? That at a certain time, at a fixed, in zero time, the displacement is changing, because at every point of time means for every displacement it is happening at a certain time, right? At a fixed time. So in zero time, some displacement takes place. Is it possible that in zero time some displacement is taking place? It's not possible. So displacement time graph, wherein the graph is parallel to displacement axis, right? A graph is parallel to y axis, is not possible. This is not possible. You can see. We can straight away say that this is not possible. Okay, right? Because it's no time, its displacement is changing, right? So in zero time, displacement cannot change. So we can deduce different type of information by seeing the graph. So next graph which we are going to talk about is velocity time graph. Okay, so let us see. I'll call this VT graph, velocity time graph. Second thing, velocity time graph, how does it looks? So let us, oh sorry, this one. So we can say that right. So from here we can say that okay, this is time, right? This time, and again we should indicate with second, and this is velocity. So this represents velocity in meter per second. Okay. So again we will try to draw different types of graph. Okay. So first of all we will have this kind of graph, wherein it is parallel to the time axis, wherein it is parallel to this axis, y-axis, wherein it is going this way, wherein it is going this way, right? Wherein it is going this way, right? So again these are 5 different types of velocity time graph which belongs to 5 different objects. Let us analyze, are they possible or not, or what information you can deduce out of that. This is basically what we are going to talk about. It's a simple. So by seeing graph 1, what can you comment? By seeing graph for object 1, we see that with the passage of time, the velocity is constant, right? The velocity is constant. Object is moving with uniform velocity. We can say that the object is moving with what? The object is moving with uniform velocity, okay? So when an object is moving with uniform velocity, so what can we say about acceleration? Can we say that acceleration is also zero? Because acceleration is nothing but it's the rate of change of velocity, and velocity is not changing for object 1. So we can say that acceleration is also zero. Acceleration is zero, right? Now we can comment on graph of object 2. In this case, what you are saying, we are saying that slope is constant, right? Slope is constant. So the object is moving with uniform acceleration. Uniform acceleration. Uniform acceleration means velocity is changing at a uniform rate, at a constant rate. Velocity is changing. Right? Now let us comment on graph of object 3. In this case, you see slope of the curve is changing, at each and every point, right? That is what we see here. So what is that? The object is moving. The object is moving with what? The object is moving with non-uniform velocity. The object is moving with non-uniform velocity. Non-uniform velocity. Right? Let us comment on acceleration. Acceleration is on this point. Go and calculate the slope. This point you go and calculate the slope. Slope is also varying, right? Slope of the velocity time graph gives us acceleration. So acceleration is also not uniform. Acceleration is also not uniform. Is also not uniform. Right? What we can comment? Same type of graph but in the reverse order, right? So here also you can say that the object is moving with non-uniform velocity, right? It is, the velocity is decreasing, right? The velocity is decreasing. Retardations, right? It's a case of retardation. Uniform or not, or non-uniform retardation. It's a case of non-uniform retardation. Non-uniform retardation. Right? How about this? With the passage of time, with in zero time velocity is increasing. It's not possible. Not possible. So with the help of different types of graph, distance time graph, displacement time graph, sorry, velocity time graph, we can deduce different types of information from the about the motion of the object. Thank you.